Hello, welcome again. We are solving some questions of industrial engineering. The topic is economic order quantity and break even point. Question number 9 is there are two products P and Q with following characteristics. Products P and Q, and then demand, ordering cost, demand in units, ordering cost in rupees per order, and holding cost in rupees per unit per year. For P, the demand is 100 and ordering cost is 50 and holding cost is 4. For Q, demand is 400, ordering cost is 50 and holding cost is 1. The economic order quantity EOQ of product P and Q will be in ratio option A 1:1, option B 1:2, option C 1:4, option D 1:8. So we'll drive the formula for economic order quantity for these conditions. So and we know that the total cost here is your cost per piece into demand plus total ordering cost. Total ordering cost is ordering cost into number of orders, and total carrying cost, and carrying cost is holding cost per unit per year into quantity to be held. Okay, so suppose cost uh, per piece is C and demand is given as 100 for product P. For product P, the demand is 100 and cost per piece is cost C. Okay, and the ordering cost is given as 50 per order, and number of orders are 100 by Q. Number of orders are 100 by Q. 100 is uh, total quantity or annual demand, and Q is your ordering quantity, or we can say it is economic order quantity when we differentiate it. Okay, to minimize cost. And holding cost is 4 per piece, and number of component to be held is uh, total divided by 2. Average number of component to be held is total divided by 2, that is sorry, economic order quantity by 2, that is Q by P. Okay, per year. So to minimize cost, we have to we have to differentiate T with respect to Q, and then find out, and then put it equal to 0, and then we find out Q. So as this is independent of Q, so the differentiation is 0, and its differentiation will be 15 into 100 by Q square, and the differentiation will be 2. So by putting it equal to 0, we can find out Q or EOQ, or that comes out as 15. Or we can directly use that formula, Q is equal to root 2 AD by H, where A is your ordering cost, D is your annual demand, H is your holding cost. Okay. So either of these, if you can remember this formula, then it is okay, and otherwise you can drive this formula in the examination. Okay. So EOQ for P. Okay. Now similarly for Q, now suppose C is again the cost of component, and number of annual demand is 400. Okay, so that is your component cost, and uh, ordering cost is 50. So number of orders are total number of components divided by economic order quantity. Okay, that is 50 into 400 by Q, and total holding cost is 1 into Q by 2, or average component to be held per year. Okay, that is, and Q is a ordering quantity or economic order quantity. Okay. For minimum cost, again this dtq by dq should be 0, and it depends 0, and it depends for 50 into 400 by Q square plus 1 by 2, and Q here is 50 into 400 into 2, or your Q is equal to 200 units. So now for Q, the EOQ comes out as 400 units, and for P, EOQ comes out as 50 units. Okay. So the ratio is 50 by 200, or 1:4. So answer is option C. Or if you are able to remember formula, if you are able to cram formulas, then for simple condition, the root 2 AD by H where A is your ordering cost, D is your demand, and H is your holding cost. And now for the given condition, for given two conditions, we can directly find out for your EOQ for P and then find out ratio, that is 1:4. So answer is 9C. But in the gate exam you have to remember lots of formulas, so avoid cramping formula and just see the basics. Okay, so EOQ is your 50 for product P, and you and 200 for Q. So ratio is 1:4. So answer is option C.